And this is the continuation part of class B power amplifier. Next topic, class AB power amplifier. Class AB power amplifier. See, we discussed in last session. There are some disadvantage. Okay, so there are some problems in a class B power amplifier. So crossover distortion. Okay, so the crossover distortion we have to eliminate by pushing some bias voltage. Okay, so the bias voltage is nothing but a VBB by 2. We are giving positive to the suppose a QN transistor, and here VBB by 2 minus voltage we are giving to the negative voltage we are giving to the QP transistor. Okay, so what we discussed in suppose last class for about crossover distortion means after cutting voltage both transistors are conducting. So here what we are doing means the small quotient bias on each output transistor to eliminate crossover distortion. So what we are doing means we are giving that cutting voltage. So whenever the positive cycle directly it is conducting, it cannot suppose wait for 0.6 volts. Here also same thing. Whenever the suppose a QP transistor conducting mode, it cannot suppose to wait for the 0.6 volts. Okay, directly whatever the cycle we are giving, whatever the source we are giving, directly positive cycle, for a positive cycle QN transistor conducting and a QP transistor not conduct. That means that will deliver the only DC voltage. Okay, and for a negative half cycle QN transistor not conducting and QP transistor is conducting, because that is the PNP transistor. Okay, so like this we can eliminate the crossover distortion by using the class AB power amplifier. Class AB power amplifier means it conducts more than the class B and less than the class A power amplifier. Class A power amplifier, this class AB power amplifier conducts less than 360 degrees and greater than 180 degrees. So how suppose the transistor conducting means by providing small amount of bias voltage to both transistor. So class AB voltage transfer curve, this is the transfer curve. The slope both output voltage and input voltage is same up to certain level, and after that point that becomes short circuit. So this representing theta 45 degrees. So if you draw the like transformer curve for class B AB power amplifier. The next one is disadvantage in class B power amplifier. Efficiency is poor compared to the class C power amplifier. Better than class A power amplifier efficiency having class B power amplifier, but the class B power amplifier efficiency is less, that is less than 80%, but we need 100% efficiency. So to achieve that efficiency, we are going for the class C power amplifier. Class C power amplifier gives the efficiency nearly 100%. Nearly 100% efficiency provide class C power amplifier. So what is class C power amplifier? First of all, class C power amplifier means the transistor operates below the cutoff region. Transistor operates below the cutoff region. So that is called class C power amplifier. That means the transistor conducts the below 180 degrees. So how we are making transistor below 180 degrees means by providing here VBB bias voltage. See, VBB negative voltage. So negative voltage we are giving to the N region. So the transistor is NPN transistor. We are giving negative voltage to the N region. So that becomes reverse bias. So more reverse bias means your operating point shifted to the below the cutoff region. operating point shifted to the below the cutoff region. So the transistor conducts below 180 degrees. Okay, so whenever the input signal given to the Q1 transistor, Q transistor, generally transistor we are representing with Q. So for past half cycle, after this bias voltage, this transistor conduct, and for a negative half cycle this transistor won't conduct because it becomes reverse bias. Okay, so see the signal. So when it reaches the suppose a VBB plus VB voltage, VB is the bias voltage and VB is junction voltage. After that voltage only your transistor comes in active region. So transistor conducts when input exceed VBB plus VE. Okay, so this is above signal is input signal, and this one is next graph is representing next waveform representing collector current. Okay, the simple concept, by giving bias voltage we are making transistor below the cutoff region, means the operating point we are making operating point below the cutoff region. So transistor conducts after that bias voltage and junction voltage. So this we can say the transistor in class C power amplifier conducts below 180 degrees. So this is the load line operation. By giving low line LC operating point below the cutoff region, AC line extended, AC load line extended. So whatever the suppose VB signal, so that signal only appear to the suppose output side. So by seeing this load line, the signal conducts, the transistor conducts only half cycle, below the half cycle. Okay, because your operating point shifted to the below cutoff region. Okay, so this is the load line operation, and the collector current and output current, collector current and output current. So collector current and output current, see this one collector current conducting less than a half cycle, and this one is a load current, full cycle you are getting. So comparison of amplifiers, if you compare the amplifier, all the amplifier operating cycle, okay, class A power amplifier conducts 360 degrees, class B 180 degrees, class C less than 180 degrees, class AB 180 to 360 degrees. Position of Q point, center of load, Q point located in active region, so that is a class A power amplifier. On x-axis cutoff region, below the x-axis means below cutoff region, and the operating point located between the x-axis to center of the load. Efficiency poor in class A power amplifier, that is 25 to 50%, class B 78%, class B 78%, class C high means it mostly reached to 90%, 95%, and AB 78 to 50. Distortion, no distortion in class A power amplifier, distortions present in class B power amplifier, and more distortion in class C power amplifier, somewhat less distortion compared to class C power amplifier in class AB power amplifier. Next, distortion in amplifier. Yeah, next one is distortion in amplifier. Distortion in amplifier, generally, so without distortion there is no amplifier, but we can control the distortion. How we can control the distortion means by using feedback network, feedback circuit, we can control the distortion. So what are the distortions there in suppose amplifier means amplitude distortion, frequency distortion, phase distortion. So now you are seeing amplitude distortion. So not it is amplifier distortion, it is amplitude distortion. Okay, so so how we are supposed getting the amplitude distortion means, so if operating point in not in fixed position, means not in active region, so definitely you will get the amplitude distortion. That means the cycle, positive cycle or negative cycle, maybe it is shifted to the saturation region or cutoff region. So amplifier distortions can take on many forms such as amplitude, frequency and phase distortion due to clipping. So now you are seeing, suppose some part clipped here. Okay, some part of amplitude is clipped. Okay, so amplitude clipped here, positive clipped or negative half clipped here. So you are observing from this graph. Okay, so this is the amplitude distortion. Okay, so means, per suppose you are giving input signal is high, so you are not getting the, suppose the same frequency and phase frequency must be constant, and amplitude only we have to suppose raise the input signal, but your voice, for suppose your whatever audio signal, high, for suppose you are giving, so you will not get the, suppose increased amplitude, you will not get the, suppose at output side, so that is called amplitude distortion. Okay, so this is about amplitude distortion. The next one, frequency distortion. Okay, so if your input signal frequency is f, okay, you are giving input signal frequency with f, if you are getting output signal frequencies to f, 3f or any, suppose a harmonic components is added to your input signal frequency, that is called frequency distortion. Why? Because your frequency must be constant. Okay, amplifier only amplify the input signal amplitude, that's it. Okay, if you are getting distorted frequency, that means if your input signal frequency is f, if you are getting output is 2f, 3f, like that, so that is called frequency distortion. The next distortion is phase distortion. Okay, so if your input signal frequency starts input signal phase starts from suppose 0 to 180 degrees for one cycle. If you are getting opposite, means the phase difference from output to input, that is called a phase distortion. The phase difference between input to output, that is called a phase distortion. So generally you can observe in suppose sometime in videos, some of the videos you can observe, sometime you can see the picture, then after that you can audible the voice, you can see the voice. Okay, some first picture then voice, or first voice then picture, so that kind of distortion is called phase distortion. Okay, so this is the discussions about distortion and a power amplifier. Thank you.